Yeah. So, do you have any specifics or questions or something you'd like me to show you, or you want to show me your models or something you'd like us to look at? You have your hand up. Okay. Well, that's a strange cube. Go away, strange cube, and I will make a normal cube. All right, let me try to sort of there. We'll add some stuff. So there I have a face. And what are you trying to do to the face? Should we, do you have it on the server? Okay. Yeah, because it could probably be a million things. Uh, uh, yeah, we can take a look at it on the lab. But essentially, if you're trying to insert an edge loop, or yes, so it doesn't go through the face. Yeah, so there's these things will happen because it doesn't really care about whether or not you did a Boolean. It's just there's some problem probably with that polygon. So it could be that some of these vertices are not merged. Did you check for that? Did you? It still doesn't work? Okay. Yeah, so then we would have to look at it. We will find a solution, but I need to see your models. So if you don't have it on the server, yeah, we'll look at it later. So, does anyone have anything that you brought with you or to the server or something? No. Okay, so then thank you, and that was it. No. Since we're here. No, okay. I kind of figured. So uh, that's okay. If you want to have us look at something here, you can put it on the server, and I'm able to access the server, and we can actually look at it in front of everyone. Sometimes this is kind of informational for everyone, because what's your name? Gunnar. Gunnar's topic would probably be relevant for you, right? Yes. Okay. Anyways, so scratch that. We'll look at it on the lab. Feel free to ask me any questions later. We'll try to sort out issues you're having with your modeling. Things will be good, and you will be less stressed. So, all right. So let's today then we're just gonna keep going a little bit, and we'll start looking at how we can actually model sometimes starting from curves. What's going on in the back? So who may have tried this? I wonder. One, two. Okay. These are also quite powerful features. What have you been building with curves? Really? Oh, okay. You like curves. Yeah. So it used to be a point. Okay, so initially, people started out modeling with polygons, and it seemed very kind of limited because they're cubes and they don't look nice. And so then there was a period in which people would use a lot of curve modeling. Uh, yeah, but, essentially, maybe you have pressed this menu and you've seen that there are some strange things in here that look an awful lot like polygons, but they're not. Look at this weird creature. If we hold right mouse button, you can see that, oh no, what are these? Surface patch, surface point, control vertex. This is weird. This is NURBS. Anyone know what the abbreviation stands for? Non-uniform rational B-spline. Anyways, weird word for a weird thing. This is a surface. It's built of curves. It's not what we've been doing. And it's kind of limited because even though they look very nice, I can't just grab this and extrude it and do whatever I want with it. So arguably it's frustrating, and I am one of those who think that NURBS are frustrating. You are not. You love them. And this used to be the case. This used to be the case. So if 20 years ago, I would have been miserable teaching this class because it used to be a point at which people thought NURBS would be the thing, and you'd have like creature modelers struggling with these patches, and it used to be a nightmare. Yes. But they're still useful. You can still use curve. So don't scratch everything I'm saying. If you don't agree, feel free to experiment. But to me, it doesn't come near the strengths and the simplicity of dealing with polygons and then simply converting to subdivs. But for some instances, like we're going to look at now, you can use curves. And guess what we're going to build? What? Bob? Bob? Oh, Bob the Builder. Yeah, yeah. No, see, that would be difficult with NURBS. It would be frustrating again. No. Okay, one more guess. Good guess, based on experience. No. I'm going to start typing. Yes. Right. Take your pick. I would keep it simple. We can go for the Utah teapot. Right. Kind of like that. So that's a very low image. That's okay. We'll use this. How do I do that? Open image. That's okay. So just so we have some reference. So the first thing we do, we grab a reference. Yeah. So go there. Yes. So we're going to try to find Photoshop. Why does this happen? I don't know. There. Okay. So we have this image. Is it a 1:1 resolution? No, it is not. It is image size pixels. So you see it's not 1:1. How can we make this 1:1? Probably the most simple thing would be just to make a new document. And I don't need this to be larger than necessary, so let's just say, yeah, okay, so 256 by 256. Yeah, no, don't close, make it. 256 by 256, create. This is 1:1. Then I go here, and I hit Control A for all. We'll select everything. And then I can hit Control C for copy. Then if I want, I can hit Control D for just deselect. That's okay. Then I go there, Control V. Ta-da. It's now in 1:1. I could have made it smaller. I could have made a 128 by 128, but it's okay. So I can go to layers. I can click, if I double click the background, I can say, okay, now it's no longer locked, and I can go maybe paint bucket, and I have to, where are my colors? Oh no, it's down there. Everything is clipped. Doesn't matter, so I'll just sample. If you hit this eyedropper tool, you can sample and color, and then I go back to paint bucket, and I can fill the background. Yay. And then I can hit save as, and this will be teapot. Let's just do a nice little PNG uh, teapot. This will be my reference. So the thing about, okay. So this is nice because now I can just make a plane. So let's get out of this surfaces menu. And here we're back to our familiar polygons. Nice. Then we'll make a plane. And here I can make a new material. I'm going to make a material called surface shader. A surface shader, I mean, we've done the Blinn, right? We've done the Lambert. Surface shader is even more simple. It's just a color, essentially. So out color, that's where we're going to plug in a file node. I'm going to turn off the filter. This is kind of like a blur. I don't want the blur. And not dude. Let's see. That was the other class. All right. So what do we need to do now before we start working? Yes. What do we need to do before that? Yes. 10 points. Always. So now this actually starts becoming a little bit important because now we're going to start introducing textures, references. Well, let's see. Maybe some textures today. Project window. New. Oh, I put CGR2. That's wrong. That's what's confusing me. Okay, there. So there. This is then teapot. Yes, if you're Icelandic or Norwegian or from other region of the world where you have strange letters, o, and so forth, don't use them here. Maya doesn't like it. So accept, so teapot, good. Then teapot reference, copy, I'm gonna put it in directly now in source images. So everything that goes into a material, in other words, any textures that actually go into a material, should be in source images. Control V, that's a PNG, nice. And then, oops, I just gotta now set the project. And so, yeah, okay, so it's the correct one. So this should go directly here. Yes, so now everything is working. So select that. It's a one-to-one image, so if I press now number 6, I should see it there. And since this plane is completely one-to-one, everything is perfect. It already has UVs, which we will talk about next time. If we open up the UV editor so that you can get a glimpse into the future. This is what we'll be looking at next time. So you see the UVs of the plane is in 0 to 1 perfectly. So it just means the image is just perfectly on there. Yes. Nice. And then as far as the orientation, we should always consider when we start modeling that the z-axis should be the front of the object. Yeah, let's worry about that a bit later. But anyways, so here I can, or not. Why can't I rotate? Oh, there we go. So my rotate tool is set to discrete rotate. If I hold E and I hold left mouse button, discrete rotate. Okay, so I'm rotating it. And I can scale it up. Should we talk about scale now? Because we've never talked really about scale. Thank you. So what's that? Yes. Scale is fuck. So then we can go teapot, measurements, whatever. I don't know. What does this say? We can eyeball it, obviously, which is what I'm gonna do. But it's like, okay, so 23 centimeters. Okay, all right, 23 centimeters. What would you do in Maya if you wanted something to be 23 centimeters? Do we have a creative suggestion? Cube, create. These are actually centimeters. So, man, I can do a little like 23 cubic centimeter cube. That's it. Whoa, looks huge. Can't be right. Yes, it's right. It's just because that initial little project is actually kind of tiny, but this is all scalable. So if you've been modeling down there, you can always just scale up your models to that specific number and you'll be fine. Now the grid is annoyingly small here in Maya, so there is one thing you would not do, depending on the pipeline, but most often and definitely 99% of the time, you do not want to do this. You do not want to go in here and change this from centimeter to meter, let's say. Don't do that. So that's it. That's okay. So then this is right. So 1 unit is now 1 centimeter. Yes? I don't know. That's just the way it goes. I mean, it's just to keep this will be predictable in most pipelines. Also, the way Maya is currently set up, like if we're doing a render, we want correct fall off on the lights. In other words, centimeters. Good. Convincing answer. So, but it's annoying. So then we go to display grid options. We can add a unit there. We add a 0. Grid lines, I add a 0 before the, there we go. Now you might encounter other problems. So because now our scene is larger, so let's say I make a cube which is enormous, so 2,000 centimeters. So, oh no, that's go away. Oh yeah, I forgot this one. If I have all the axes, 2,000 centimeters. So there, you see, it disappears. Oh no. What's going on? This has to do with the clipping planes on the camera. Okay. So when you scale up the thing, now the scene is larger. We just need to go in here, select camera. And then we have something in the camera, which is called near clip plane and far clip plane. Here, since it's such a large scene, I can probably scale this up, like put 1, and then add a 0 in there. Oops. Now I can go further away before that starts clipping. See there? It's still there. And I can actually go closer before, or well, not as close anymore, but having that clipping plane set too low can actually cause some artifacts when the scene is larger. Yeah, so that's essentially that. So if you're experiencing, oh, the other thing when you're working, so now I want to sort of be framed around this object. This also becomes more relevant if you have a very large scene. You press F. It sort of frames everything to that object again. So there, okay, so now at this scale, I would have to adjust the clip plane. Set it to 1 seems to be, yeah, that will be fine. Just, you see, if it starts clipping, it has to do with the clipping planes of the camera. Yep. Like that. Middle mouse button. Hold Alt and middle mouse button. You do need a 3-button mouse for Maya. So if you don't have a 3-button mouse, who's this person? Yeah. You hold middle mouse button. Oh, you've tracked the camera motion. Oh, I don't even know. Here? What do you do? Camera tools. Oh no, I don't know. Yes. Yeah, don't do that. That would be, I don't even know. I guess, does anyone know? I guess like for animations, if you want to like have a nice camera track, right? You could use that. I guess, or this is to like walk around as you would in a game or something. Really? Yeah, so don't do that. Just use middle mouse button when you're navigating. So anyways, so yeah, so we're back to this. 23 centimeters would be like that. So then I guess I could scale up my little reference thing. Press 5, press 6, and scale that thing up. And there we go. And I could go to press 6 here, go to front view. Whoops, just scale that in there. So I can't now go to wireframe because then I won't see the reference. So I gotta be in number 6, which is textured mode. But I can go here and do X-ray. They made a button for it. Where's the? Yeah, there's a button for it. X-ray. That will just, as you see, will create a little ghosting on the thing, so we can see through stuff. Yes. So then I can just match this reference image to that little 20, what was it, 4 centimeter cube, and maybe kind of align it more or less to the middle of like X0, right? Kind of like that, and then I'll move these guys up. Yeah, so that's it for if you want to scale something, you can just make a measurement cube and it will be very accurate. And so the units here are centimeters, right? We also have like measurement tools here. So distance tool. So if I go and place a point, and I can place another point, this will give you the distance in centimeters between these two locators. So it creates two locators, and then it gives you the distance between the locators. Very simple little script, but it's a nice little tool if you want to measure distances. So I can go distance tool and hold X, or not. If I hold X, it will snap to grid, but let me just measure across here. 39. Didn't we? What did we say? 20. Hang on. 23. Oh yeah. Again, due to my brain, I scaled it incorrectly. So there. You get the idea. It should be 23 then. Yep. So the measure tool is kind of nice. So you get these two locators. Yep, so 23, okay, so it should be there. Go away. Measure cube. Oh no, wrong one. There. Yep. So you can be very, 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 very precise with measurements because you could say, 23 point dot 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 many decimal numbers. So you can be as exact as you want. But here, so this is a little bit like rough estimate to get that in the middle. All right, let me just delete these locators, and I think I'm ready to save the scene. Teapot 01. Okay, so as long, like this is one way to import a reference image, which I just kind of like. You also have image planes. You can import image planes. But if you have a simple reference image like this, we can throw it into a display layer. In the channel box, if you hit Control A to toggle attribute editor and channel box, here we have display layers. And this button will add something, or it will create a new layer and it will add the selected object. So now we have a layer with this selected object. That's it. We can also turn that off. So now it's just like it's not there, but it's there. See, it's not even hidden. It's just in this display layer. There's one more thing we can do with the display layers over here. We can click there. Now it's a template. So we can sort of see where it would be if it were there, but it's not there. We can click again. Now it's a reference. We can't touch it, but it's there. So that's very handy for this purpose. Now it's there, it's just a reference, we can't touch it. And then, or click it again, now it's just back and we can touch it. So the point here is it doesn't matter how far back you push it. See there, it doesn't change here in the front view because the Z axis is just missing altogether, right? In that view. So that's why this kind of works. You just make a plane, you attach a one-to-one image, put it in a display layer, and then it doesn't really matter where you put it. Well, you can put it here if you want it next to you so that you can sort of see it also in the perspective view. But then turn it into a reference. And now we've gotten to the point where we can look at what we were going to look at, which is how to make something with a curve. So there are different curve things here, but the one we're going to use is CV curve tool. So it's just control vertex curve tool. We briefly used it before. What it will do is that it will create kind of a straight version of the curve based on these control points. Very similar to the effect you would get when you subdivide a plane, right? We tried that. So we have vertices, subdivide the vertices, you'll get a curved result. Here we have a straight version of the curve. These are the control vertices, and you see the curve underneath. When you hit enter, you have to hit enter, then it will create the curve. If I right click now, I can select control vertex, grab the control vertices, and move them around. Nice. If I go to so curves, you sort of need to draw them in one of the orthographic views. Otherwise, the points will be all over the place. So there, but you see they're all like precisely on 0, Z, and that's it. So we can do various things with a curve. Let's just look at revolve, which is very handy for this example. So the way this works is that we're going to establish a profile curve. So in other words, you see this object actually has a very, it is symmetrical. It has a radial symmetry. It's circular and symmetrical. If you ignore the spout and the handle and the lid. So often in modeling, when it comes to, now we're starting to get into a little bit more complex shapes, even if eventually the handle and the spout will be a part of the same mesh, it's beneficial to not do that in one operation. So first you have to simplify the form. So I see a simple form here, and then I would add that and that later. So that's what we're going to do. So create curve tools, CV curve tool, and here, I guess I can hold X, just snap it there. And so the first point you place, can I hold X again? No, never mind. The first point you place, just place it like a little bit off from that initial point, just to get things rolling. And then the placement of the vertices now will sort of define the polygonal density. Eventually we will be converting this to a polygonal model. So it does matter in the sense that it sort of defines the poly count, essentially. So here, to establish that kind of close in curvature, I just place 3 control vertices. Again, this is similar to when we were doing subdividing and sort of that mindset. And here I can just keep building that curve according to the profile. And I only have to do this to one of the sides, and then we're going to revolve this. Whoops, just undo that. We're going to revolve this around itself. So here, just close that up, hit enter. There's the curve. We can also edit the curve after the fact, but here we can go surfaces. So this is a whole menu dealing with surfaces. We have revolve. Now it revolves a surface around that profile curve, or based on that profile curve. So if we observe it in the perspective view, here we go. So added benefit, we can grab this profile curve. Okay, now we gotta kind of carefully select it and say control vertex. Nope, it's not that one. So if I would not be recording right now, I could have selected the curve here and then press F9, I believe. Then I would see the control vertices. I'm not going to do that because it's going to kill my recording. So you can also carefully kind of go in here and make sure that is the curve you're selecting. But here I can grab the control vertices, and what you'll see now, well, it seems like my move tool is, okay, let's just try it. See there? I can update the curve and make a lamp. Right? So that's the power of this. You can have this instant update. So it is very powerful. All right, so then if I right click again, you'll see that, oh no, what are these? Surface patch, surface point. This is a surface. So in order to keep working with this, we can convert it to a polygonal object. We go modify, convert NURBS to polygons. So NURBS, that just means kind of like surfaces to polygon. Options, different options. This is a very simple option. It will literally just look at the control points and convert that to a polygonal mesh. Apply. So here you see in the outliner, here we have the revolved surface. It's still there. Here's the curve. Let me shift select those, control H to hide them. Now they're gone. Here's the polygonal object. And that's just the polygonal object. And here, this will be familiar. So face, vertex. Very nice. We're back to this world. And it looks crappy. But we can press 3. And it looks good. So the power of subdividing then means we can keep looking at this as a curved model. It's a nice ringtone. And then, but now we can also grab, for instance, these faces and extrude and do whatever we want. And this is sort of combining then the initial power and potential of NURBS. now with the power of polys, because this is something that's very difficult with NURBS. Like you can't really, you don't have the same level of control. Right? Any questions? No, you can delete them. No, no. If you were worried that they might be affecting it, what would you do? Tr Just delete them? Yes. Delete history. And then sometimes, yeah, let's not get into that. So delete history. Sometimes what also kind of works is just to copy the mesh. You have a fresh mesh. If that doesn't work, you can export the mesh as an OBJ. Then it will definitely have no connection to anything because it's just a geometry. OBJ means, just stands for object, so you can export any mesh and import it back. Okay, perfect. So we all kind of got that. So once you sort of get subdivisions, which you already kind of do a little bit, and then you see now we can combine these powers. And okay, one thing though, just one little thing. Oh, yeah. So this is all set to soft select now for some reason. So if you see this, like this is now soft select mode. Does anyone know the hotkey? Huh? Really? Oh, thank you. Ah, extra points. Perfect. B. So, okay. So sometimes you'll see that activating, so it's very helpful knowing the hotkey. If you didn't know the hotkey, you would do like me and hit reset tool and sort of that would go away. Or you can also find the soft selection here. So B, yeah, yay, nice. Okay, okay, so yeah, so the initial point though, we're gonna explore. See, that's 8 vertices. So that's the only little kind of workflow thing you need to remember doing this specific thing, like starting out from a curve and then using revolve, is that you go to the middle one and merge it. Now everything should be good. And we couldn't really spot that because normally when we subdivide, it would create strange artifacts if something is not right. But since that was such a kind of just one point, it didn't really cause any artifacts. It would be very hard to even spot. So I guess you sort of have to know. Okay. Nice. Questions? Yes? Yes. There's a hidden vertex. I don't know. Will it fix that? Maybe. Let's see. It should. So a hidden vertex, in other words, would mean that it would make. Let's try to make a hidden vertex. So I would make like a. If I make an edge and then I delete that edge and I forget to delete the vertices, now there's actually vertices there, but I might not know about them. And when I hit subdivide, it will see, strange things, definitely causing artifacts. And another thing that those little vertices are actually doing is that they're making this face no longer be a quad. It now has 1, 2, 3, 4, 5 edges. And this one would have 1, 2, 3, 4, 5, 6 edges. So that's actually never okay in a mesh. You can never have n-gons or faces with more than 4 sides. So we have something called cleanup. So as you see, this is sort of to help you kind of spot errors in the mesh. It will just analyze the mesh. And so what I like to do is to set it to select, because then it will only show you if there's a problem. You can set it to cleanup and it will just try to fix it. I prefer just Okay, show me the problem. So it should show you faces with more than 4 sides. See that? And that's something you never want, right? So let's see if that will work. So just like that. Yeah, there it shows me those faces, and I know that, okay, that's a problem. So that let's ask it to fix it. I would just delete them. Well, let's see, clean up, see if it will take care of it. No, 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 no. So maybe there's probably a setting in there where you could set it to not make tries or something. But that's a wacky solution. So I would go select, and then I'd rather just analyze this. Oh, okay, quick fix. Go away. And then there, so if you see nothing is selected, it means, okay, there are no faces with more than 4 sides. You have to be a little bit kind of, doesn't always work. Usually works. Another thing is you can select all the faces with 4 sides and it will select everything. And then you can invert that selection and it will do the same. Oh yeah, at the bottom, I didn't see that, but it probably selected those. Those are tries. Oh no, yeah, they're tries, right? We have a lot of tries at the bottom. Tries are technically okay, right? So you can have some tries. Uh, oh yeah, so it just that the faces with more than 4 sides will not show you the tries. So if you wanted to like spot all the tries, you could do this. So select 4-sided faces. It will select all the 4-sided faces. And then if you quickly wanted to just see which ones weren't, you would invert that selection, right? So here, and then hold Shift and do that selection marquee, and it will invert. And then you could even hit like Shift I, and it will isolate everything for you. And then you have like, so this becomes very useful. Like if you're working with a large mesh and there's problems in it and you have a lot of issues to address, this could be kind of a quick kind of fix. So you would clean up, you'd set it to 4-sided faces, and then you'd invert the selection. So I hold Shift and marquee select, and then Shift I. It will show me all of those. Then if you have a lot of issues and it would take you a long time to address it, you can also then just assign actually a surface shader, for instance, to those polys. So if I, for instance, make this surface shader red, this is like if some of you have larger meshes and you really have a lot of issues, this will highlight them in a kind of very manual way, but you will see all the problems in that large mesh and start addressing it. Like you have to go over, and then, and once you've kind of dealt with it, you would select them and just say, yeah, and now I'm done with that, so I'm just going to assign Lambert 1 again, and that's that. I wish there were a script for that in Maya. Maybe there is, but that would be nice. Which would just kind of color code all non-quads, for instance. Which is essentially what we're doing here, manually. Okay. Yeah, so the cleanup, you can experiment with that. It's very nice. Okay. So, yes? Yes. Let's take a short break. Let's actually take 15 minutes. 15 minutes. Mm-hmm. So, who has started doing the optional one? Optional? Don't forget about the optional assignment. Don't forget about the optional assignment. No, don't forget. Don't. Yeah, forget about it. No, don't forget. Don't. Just kidding. Yeah, your own CG asset. I recommend people doing it. It's not up. It's not mandatory, but why not? You're having fun, right? Modeling. Yes. So we have this thing. what are we going to do? It has no thickness, right? How can we see that it has no thickness? Yes, there's a bunch of planes. We can see that it's black on the back sides of the polys because two-sided lighting is turned off. If we turned on two-sided lighting, it would be kind of more difficult to see. But it's actually pretty nice that it is turned off now by default because essentially we do not want to see the back faces. Yes. Does the base teapot need thickness? Essentially, nothing needs thickness. It's just that we never want to see the back faces. Yes, exactly. So if you had a lid going on top, you wouldn't necessarily need thickness. Depends on your needs. Like if it's a static asset and you know that the lid is always going to be on, yeah, it doesn't need thickness. If it's in a game and you're able to utilize it and open it, or in a render or whatever, yes, it needs to have thickness because you at some point you would open it. But these are relevant questions. You have to ask yourselves what are you going to use the asset for, and so forth. And they would be customized to that. So if you knew that it was a static asset, it would never be opened. It would be more beneficial not having thickness because it would have fewer polygons. You would save texture resolution also. So you wouldn't have to have any UV space or anything. But, or if, yeah. For most cases though, it's kind of nice to have physically plausible models. So how could we add thickness to this thing in a very simple way? Do we have any suggestions? Yes, exactly. So I can copy it just to try it over here. I use the extrude tool and I'm going to do it in object mode. So this is just in object mode. I'm selecting the object. I use extrude and I can go pull it out along the local Z, or I could have used, yeah, so here's local translate. See, they have it right there. Or offset, thickness. Thickness would do a similar thing. And that actually creates a uniform thickness all the way throughout. So then I go to object mode again. Now I can subdivide it, and you see now it has thickness, and we get that interior. Very nice, and I can go in here and look inside. See there? There. So this is more physically plausible. I could 3D print it. You know, it's just, I kind of like to look at it that way. How could you convincingly make something that could be 3D printed? It's kind of a nice brain check to see if your model makes sense. Because this is now what we call kind of a manifold mesh. Everything is connected. You can go inside and have a look. Right. Nice. So that's a quick, easy way to create thickness. So knowing that, I don't have to create the thickness yet. I can keep working with this simple model. Kind of the same mindset that we started getting into last time, where you hold off making thickness until you need to. So when we were doing the modeling from planes. In case you haven't tried it yet, I highly recommend try sometimes starting out from planes. So last time I showed you, I'm not going to do it again, but it's just you can repeat the last lecture. But essentially, you can extrude edges, right? So I'm extruding edges. I can do wonky shapes, do whatever I want. And I don't have to worry about thickness, which is a huge benefit. And then I do whatever I want, and then at some point, just in object mode, extrude, pull it up, or see that it creates a little bit of a not so uniform thickness. So here I'm going to use the actual thickness function, which will keep more of a uniform thickness, which is nice. And then what I did last time was that I extruded this out so that we get a nice creasing edge all the way around. And I extruded it once again, pulled it down a little bit. And here I'm going to use offset. So you see offset and thickness, these functions are actually a little bit nicer at keeping things more uniform instead of translating according to the normal or to the object. And then I could subdivide it. Seems like something's funky with it. Anyways, you get the idea. From planes, go on, subdivide it, and there you go. So same thing here, same mindset, keep things flat initially. So what I like to do is I make copies of things. So, and again, I treat this as my workbench. So I reached this milestone, I'll just push that over there and whatever. So if I need to revert back to that, it's right there. I have it right there. I can keep working on this guy. And now maybe we can try to address something like the handle. There would be various ways to do the handle. There's not a right way or wrong way. You could literally start from a cube and just extruding out. You could start from a plane, for which you would then paint sort of the profile of the thing as a plane, and then you would extrude the plane, and then keep working. Let's try I think you kind of get that, right? You could do that. But let's try another way we could use curves, since we're talking about curves. So I could have started with a cylinder if I wanted, but I'm going to start with a simple cube again. So if I place the cube more or less at the starting point of the handle. So see, it's very beneficial now to use these orthographic views. So I'm just getting that placement. It's a very low resolution image, but it's okay. It kind of gives me an idea of the placement of things. Granted, it would be better if I had a little more resolution, but it's okay. And then what I'm going to do is I'm actually going to draw a curve again using a CB curve tool. So then starting more or less in the center of that poly, but I'm going to, since it's just initially placed using the orthographic views, it's exactly on 0Z. Like it's on the grid, so that means I can actually just start drawing the curve from the orthographic view, and that should place it more or less there. Otherwise, we could always move the curve after the fact. So you start the curve, then make one little point at the start, and then you keep going. So here, and again, the placement of these will sort of define the polygonal spacing, like the spacing in between your edges. So there we go. There's the curve. I can see in this view. So what I'm going to do, I'm going to literally grab this polygon and make it extrude along this curve. So I can grab this poly, shift select the curve, and then do an extrude. So initially it will see it snaps straight to the end of the curve. So we have to add some divisions. And that's why we have a slider right here called divisions. We can slide that up, and there it adds divisions. So this only goes to 25. If you really wanted more, you could just type in a number there. I would suggest keep this low. Don't get so concerned with things looking low poly. And remember, we're going to be subdividing, right? And then it's going to be smooth and nice. It's just that you're limiting the amount of vertices that you have to worry about. So try to keep things kind of low. Then we're going to look at some other options here in the extrude operation. So again, in the channel box, under the inputs, this is the actual history that we always keep deleting. But in this case, we're not going to delete it yet. We're actually going to do something with it. So under the inputs, you see this is the last operation that we did. This is poly extrude. You can click here. You see here a lot of settings for that operation. We can still alter this because we haven't deleted the history, and it's kind of the last thing we did. I can't go back to this. Unfortunately, Maya is just kind of not that elegant for this. So you can't really go back in time and, oh, I'm going to change that setting. If you've done other things in between, it's not really going to work like that. I guess maybe like Houdini or other softwares which are much more node oriented, but you could do those kinds of things. Here, you have to do it a little bit more linearly. So, but what I'm looking for is taper, for instance. Taper is interesting. So here I can enter numerically, or I can just select the operation and then use middle mouse button here in the world to do this as a slider. So you can see I can taper that up or down. That's kind of useful. So there's taper, I have twist. I can twist it like that. Also, this is still connected to the curve since we still haven't deleted the history. So I can still go back in here carefully again, kind of select the curve. So so that's not the curve. So that I get the, go to wireframe, right click. So I get the control vertex. This is the curve. So it's kind of tricky to be selecting sometimes. But like I mentioned, if you click the curve in the outliner, and I believe if you press F9, that will activate control vertex. Might be a little bit quicker to do. But go in here, select control vertex. So you see it's still active, so I can kind of update the curve. Now if I activate my, it's getting kind of tricky to see, isn't it? I could do this manually. I could set up a shader that would be kind of semi-transparent. You wouldn't have to deal with this if you're using image planes, but since we're using a plane, I do have this issue of having to, let me turn off the X-ray function. Let's go to textured mode. Okay, so if I want this semi-transparent, maybe the easier thing to do would be just actually just go into the shader, right? And then I could just set that to be a little bit transparent. Even I could change the color if you prefer kind of to see those polys a little bit more clear. You just very, very easily do that however way you'd like, just manually. And then grab the control vertices. See, so maybe now it's a little bit easier to see what we're doing. Then again, I should still be able to select here, taper. So maybe taper that a little bit more. So you get the idea. Granted, annoying, I would have to go back to the, so I would make another material which would be semi-transparent, and then it would just be effective like altering them here, right? So here I can just assign a Lambert. Now I have a Lambert. Right? You'd be like one little gesture away from altering them. Okay, so far so good. So then I can subdivide both of these. Perfect, I'm done. So I think the original Utah teapot, it does look, I'm not sure, I haven't really looked at the mesh obviously, but I think they're just kind of like objects tucked into each other, and that's okay. So there's technically nothing wrong with building CG assets, having various objects just like put into each other, actually intersecting. Technically you can do that. I mean, if you whatever you're building, if it kind of looks okay, yes, you can do that. Obviously, it wouldn't. Again, if we're kind of applying the mindset of what if I 3D printed this, that doesn't really make sense because it's now no longer kind of a physically plausible solution. You're kind of tucking things and they're intersecting. So actually, I have to make this a part of this mesh. It needs to be a part of the same mesh, right? Makes sense. Depending, I mean, the lid would not be a part of the same mesh, obviously. The lid is a separate object, but the handle is not it is in a sense a separate object, but it is a part of the same, it's welded to the same object. It is the same object. But you can look at it as different objects when you're building them and then kind of combine them. So this is what we're going to do. Okay, so at this point, I would copy this. Okay, perfect. So you can sort of see the iteration that this is taking. Whoops. Nope. The iterations that you're doing, it's kind of nice to see the history just right there. Okay, let me save this. So how in the world can we combine these two objects? Actually, if I look at the shape of this, let me try to, so this would require more attention, obviously, but here I can sort of, oh, I have a little shelf, that's nice. So I can do like a little edge there. Let me shift I on this object, press F to frame the object so I can go like that. And then maybe if I wanted to scale, I can shift select, it will select this face path. Like if I select the first one and then shift double click, and we'll select the faces in between. And then I can scale, for instance, towards each other, kind of like that. And look, have a look at what it would do to the subdivision. And I would need some creasing edges at the edges to keep that curvature so that it doesn't do that rounding off. But you get the idea. But here, actually, you kind of have to be a little bit mathematical and kind of engineer this because the number of vertices would need to match. Right, so typically to make this, I'm getting annoyed with that, so let's do this. Yeah, so I mean, adding something onto here is probably a little bit more, let me see, if I just copy this just to prove my point, then I select everything else. If I have this little piece built out, like two separate objects, right, and I want to connect this piece to that piece. This would be a very simple, straightforward example. It wouldn't require a lot of mind bending to figure this out. It's like, okay, there's 1, 2, 3, 4 vertices, and I have 1, 2, 3, 4 vertices. Excellent. Then I would just delete that face, because that will be now an internal face in my new mesh. I will delete that face. Then what I need to do is actually, first I would need to combine these, so I can go that, and then here, combine. So we have, Maya has these features called combine or separate. Combine or separate. So look, these are now two different objects. If I hit combine, now it's one object, plus you get a lot of these weird transform nodes, which are, no one knows why they're there. You don't need them. How can we get rid of them? Yes. See, they're gone. So now it's one object in Maya. Technically, there's still two separate meshes, right? We can see that. They're not merged together. They're two meshes, but they're one object. That's what this separate does. It just kind of looks at it and says, well, those are actually two meshes. So separate will do the opposite. So we'll just separate them again. How do I get rid of that transform node? Yes. How do I get them out of that group? Shift P. I can delete the group. There we go. So everything in Maya is kind of manual, not very user-friendly, but yeah, it's okay. And then I combine it, delete history. Now they're combined. Now I can do things like grab these vertices, or all of them if I wanted to move the whole thing, and just move that down. But then at some point, I would have to merge these vertices, right? So I can move them into place, like carefully, and then merge them, or move and hold V, snap to point, and then select both of them and go to merge. That would merge them. There is another little tool in here which would simplify it a little bit. So merge, what is that called? Merge tools, mesh, target weld. So that's under mesh tools, target weld. And that will enable me to just go like that. And now it's kind of welding them, and in other words, merging them. There we go. So if I subdivide that, I should see that, just a kind of a consistent mesh. It's all together. If one of them weren't merged, you'd see wonkiness. All right, so that's how you do that. That's how you can combine two objects, put them together. Now they're one, right? So that's the same challenge here, except that now it's a little bit more tricky because it's no longer such a simple example. So let me undo this, or actually let me just, yeah, let me do this again, but with a trickier one. So typically, if you can think about this as kind of even numbers up from like 4, 6, 8. Typically, if you want a round something attached to something, you would need either 6 or 8 points, right? If you have 4, there's that. If you have 5, it's strange. If you have 6, you can create a very nice little cylinder. So if I make a cylinder of 6 divisions, again, this is just for our little thought experiment, and then move it over here. Let's see if I can, whatever. Okay, yeah. So, right. So now that has, come on, let me just get around those. These are like those. So 1, 2, 3, 4, 5, 6 vertices. Down here, I have 1, 2, 3, 4. I need more. So then I could, for instance, go to Insert Edge Loop tool, go to my tool settings for it. So actually, you can double click the icon and it will open the tool settings. Multiple edge loops of 1. That will insert an edge loop straight in the middle there. Now I have 1, 2, 3, 4, 5, 6. Right? They added this feature called circularize, which is trying to do a good job. Yeah, so I would do something like that. Now it's again set to discrete rotate, so it will rotate in increments, which is kind of nice. But you know, you're trying to keep things in order, so that kind of makes sense, right? And then you get the idea. Combine, merge down, and you would have it. So 6, okay, but still it's not kind of symmetrical. See, I would have a line here as well. So if I had 8, that might be a good number. So typically, I think you'll find when you're doing these modeling tasks, if you have 8 divisions, that's a good number. Right? Makes sense? And so, on this guy, we're going to commit to this shape. What do I mean, commit to the shape? I'm going to smooth it. It's kind of committing to the shape because it's no longer so easy to go back to that initial stage and tweak the curve and everything. I'm done with that. Now I'm moving on. This is another operation. So here, if I look at this, I kind of cleverly, very cleverly, oh, not so clever as I thought. It has 1, 2, 3, 4, 5, 6. Maybe I want to add 8. So let me just do that. So I do that little insert edge loop tool, and it is set to multiple edge loops of 1, so it should snap to exactly to the middle in between all those vertices. Now I should have 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay, so that's a good start. Now I just need to figure out how in the world can I get 8 vertices on here. So since I have some vertices here, I can say 1, 2, 3, 4, 5, 6, 7, 8. Interesting. Then I will try to sort of bend that to work, and that will be the origin of that handle. So there will be various ways to go about this. You know, there's no, yeah, have to try things. There's one little handy tool. It's called Slide Edge tool. Again, I don't know where they put it. There it is. Slide Edge. You click it, and then drag with middle mouse button to slide. See? Looks very much like move, but it keeps to the contours of the object. So it's not destroying that contour. She's just very nice. Yes? You can start using the multi-cut. But I don't have to do that for this. I'm keeping things still quite simple, right? Because if you're starting to introduce the multi-cut, which obviously you can at any point, you can go multi-cut. Where have you gone? There you are. And then start like, okay, figuring out this topology, and maybe you'll make some tries, and maybe, you're customizing the model. Yes, of course, you can always do that. Like I said, there's no one solution for this. But the beauty kind of sticking to quads and keeping things simple, arguably, it would be easier for you to arrive at more of a kind of an elegant solution without too much trouble. Maybe, maybe not. But it obviously will be some manual tweaking, some trial and error, But okay, so now I have sort of defined. I slided that edge a little bit down, just so that maybe now I have this could be the origin, and now I could start. So what you might guess that I'm about to do is I'm going to start snapping these over here so that it kind of connects. But remember, we want happy polygons, right? So if I do this, if I snap, okay, so I'm in Move Tool, I'm holding V to snap to point, and I'm using middle mouse button, I can snap to that point. That's the little point there on the handle. Okay, see, this polygon is very unhappy. This is very bad. It's not good. So maybe I could consider extruding this region again, not necessarily, depending on your situation. But here, offset, I can offset that in. And here, chances are these polygons will be happier because I can delete. Well, let me not delete it yet. Let me slide these over using slide edge. Where did you go? There you go. Let me add that. It's very useful. The difference is just it keeps to the contours, right? So I'm sliding it over. I could slide it over on the other side or not. I could just delete the other side and do that later, which is what I'll do. Go away. I'll also delete half of this handle. Very useful to have a dividing line, always. See there? So now we're looking inside of what is to become the model. Okay, so I know I'm going to delete these. Oops. And now this is starting to make sense. So I'm counting. I don't have to count. You see, it matches. Same number. What's going on? Oh no. Hello. I think Maya got upset for some reason. Oh, it's live. Yeah. Turn it off. So all these things can happen. If you turn an object live, it means, oh, I can't select it. What's going on? So maybe this will happen to you. I don't know the hotkey. Maybe some of you do. This is to make an object live. This is to snap things to the object. So now I could like create a curve and snap it to the object. Anyways, interesting feature. We're not going to use it for now. Okay, let me save this. I would save an iteration at this point, probably 02. So I would need to combine them. Now I'm going to delete the history. I would even copy that thing so I can see that little iteration and move things over. Let me combine. And I can try to use the target weld again. Or I could have done an extrude. Okay, let me target. Let me merge these. You're absolutely right. There. Yeah, good observation. So these faces would need to be deleted because they would end up being internal in the mesh. We don't want that. Perfect. Now we can try to press number 3. See, oh, everything connects. Same procedure. This is looking very thin, but okay. So obviously, yeah, a lot of tweaking. So I could have done the same thing. Maybe it would be easier for you to kind of see it if I mirrored it again, but I can essentially just do that and then get rid of these and then snap these to V, snap them over here. Hold V, snap, oh, snap, and then go like that. And then, oh, maybe yeah, so I probably should have not deleted, I should have slided them over. That would have been a little bit more elegant because now I'm kind of off. I'm no longer sticking to that curvature. So instead of deleting the face and then moving the vertices, what you can do is just select the edges and then use the slide edge, and it will keep to the contours of the object. So it's very nice. Yeah. And then these need to be deleted. I know that right away, so I can just get rid of them. I need to delete these. Yes, and then should we target weld then? Why not? So then we go to target weld. So it is kind of fun in a weird way. You know, there. Yeah, definitely. I should have extruded that little guy, right? So it would have been a little nicer. So now it's all messed up, but you get the idea. This would require more attention. I could, keep tweaking this just as you would anything. Just, it's modeling. You would have to tweak it. Slide edge. Yes. Okay, but we're creating the same kind of, you get the idea. It's connected. Then, since I've been sort of pulling those apart, I would now just need to make sure that the dividing line, like all these vertices would need to be aligned, right? So select all those vertices. I can go to the move tool. Okay, so in this case, arguably this would be sort of the width of the object. So I would have probably aligned this differently. So the X should be the width, right? So before exporting this teapot, I would have oriented it so that probably this would have been its X width, kind of, yeah. Right? Anyways, but I can now set this to 0Z, and all those vertices should go to 0Z. Just make sure you don't have anyone selected that shouldn't be selected. Let me undo that, just to really make sure. Yeah, seems like it's only those. So 0, there you go. Nice. Maybe I'll copy that, sort of an evolution there. And, oh, curve. Yeah, go away there. And then I can mirror. Since you have a lot of history, don't need that. Delete history, keep things organized. This should work now to mirror. So I'm going to mirror Z and minus C. So not with the Z axis, but the other way. Mirror, doesn't work. Why not? Current selection doesn't match required selection type. You're wrong. Oh, there's a curve there. It was, okay. That's extremely odd. I'm going to copy this mesh. I'm going to delete that one. Yeah. Okay. There's a button called like delete constraints, non-deformer history. You see, there was a connection there to that curve, which was a bit strange. Quick fix: copy the mesh, delete the other one. Right. That will delete. It will be a new mesh, essentially. Anyways, so all right. So now mirror. Yay. Nice. Let me, yeah, that's that. I can copy that. Very happy with it. Move everything over there. Press number 3. Wow. Wow. Oh, no. No. It's just because this is my workbench, I like it. I like that it's a little messy there. but I can go Control H and hide them. I can also do like Control G, group them, and this is sort of my work in progress, whatever. It is arguably kind of nice because you can go back to which, for whatever reason, you might not even conceive of. Maybe you would need them. Maybe not, probably not. Yeah, you can delete everything if you want. But I would suggest then keep iterating more often, a little bit more often. In any case, it's very nice for maybe for your report, for you in your case, since you have to sort of document the process. Mm, okay. Yeah, so obviously now I could do, again, just extrude everything in object mode. You get the idea. That would create thickness. But I would first do the spout. I'm not going to bore you with that. It would be the same process. It would require attention. You would have to think about it. uh, yeah. Maybe start with cube, extrude along curve, or not. Just make that shape. If you start with a cube, you can add 2 more edge loops. Now you have 8 vertices. Chances are you'll be able to connect it here, probably to this region, for instance. Right? Oh, I'm sorry, at the bottom, right? Here. Right, there's your 8 vertices, or 4 polygons. So I'm not going to spend time doing that, but just maybe just make something. So, all right, create a curve, a CB curve. I can add that function. So create a CB curve. So I sort of missed the placement there. So I would probably do this arguably before the handle in this case. See, this is where it would be very nice to actually have the other. This is an instance of what you were saying, of what we were talking about. Because I could revert to one of my other simpler meshes to make the spout. And then subdivide the spout, and then fit that to this more intricate one. Make sense? All right. Keep things simple for yourselves. You know, that's the whole point. If you could manage to keep things quads, keep working with edge loops, chances are you'll get there in a little bit more elegant way because you're kind of forcing these vertices just in place, kind of. So this is not going to look anything like that spout because, like I'm saying, I would have needed a larger area to start that extrusion. But that's why it would be elegant to use this version, right? Which I could easily just do 0, and now that's back, and I could use this as the starting point. And I would have probably then utilized, you know, maybe these, and maybe do an extrude, offset, and have a much larger starting point to work with that form, because it's a much larger form. But you get the idea. But here I'm just going to select these, so it will not look anything like the actual spot. Let me just create that curve. So you get the idea. I can create a curve again. And then, yeah, same thing. Just shift select the curve. Let's see. No, not you. Shift select the extrude and add more divisions. I could do yes, and taper. Oh yeah, and yeah. Twist. That would be funky. Let's do that. So subdivide. Yeah. Let's not do that. I'm not going to do it. It's just, you get the idea there. I'm just going to go away. It's discouraging to look at. So, yeah. Needs more attention to make things pretty. Well, we can make a lid then. I'll leave this about for you. But so here, how can we make a lid based on this? I copied the object. Maybe I can shift, double click that, shift select the rest, delete that. And I can grab just that inner edge loop and scale that in. And I can snap to point and snap, move that up and snap, hold V, snap to the other points. Then I could, for instance, fill hole. And now I could use the multi-cut, for instance, to do that. So multi-cut, you can just do whatever you want, like place an edge loop wherever. So you see the icon gets red. That means it's kind of locked on a vertex. So just be a little bit careful, because if it's not red, you're just placing it off the vertex. Okay, and then that would not be nice. So a nice workflow tip is to press Y to access the same tool again, instead of entering or hitting enter and having to access the tool. Well, yeah, it's just a one-click difference, but press Y, it will access the same tool, and I can just keep going. It's kind of nice. Hit enter, I'm done. Now those are all quads, right? 1, 2, or 1, 2, 3, 4. I could have made them tries. Technically, that would also kind of be okay. But yeah, here, so maybe I would go scale them in, hold control, I can scale in the other two axes at once, and I can go extrude, maybe in a little bit, extrude, use offset up, and kind of create that handle, which, yeah, would require, again, some more attention. I would look at the reference, because this is wonky, and here, I would not leave those there, but maybe just extrude them in to get a little bit of a nicer topology. But here, arguably, and I don't have strong opinions about this, but arguably, it might, in some cases, be better to actually have tries there. And then you can do this, like connect these. I would kind of make that area a little bit smaller so that it's not too large anyways. Oh. Yep. So how are you? How's it going? Yeah, okay. Excellent. Then I extrude that down, extrude it in. Or I could make thickness for the whole thing. If I wanted to open the lid, it would, but I could also do this, sort of, and do the same thing underneath. You get the idea. So fill hole, connect the dots. That's wonky, so maybe probably add some edge loops to retain that curvature. So I would add it over here. Whoops, and let me double click here and just say relative distance. So I can place it wherever I want. Place one there, place one there, place one there, place one there, and then subdivide. And there we go. And then just adjust that. And this needs to be subdivided. Why is it so wonky? Because it's another mesh. Oh, the NURBS has come back. Yes. It needs to go away. Yeah. All right. Any questions? Center pivot. I can go a little bit like that. Let me turn off discrete rotate. Someone kind of left the lid like that. That's cool. So kind of a strange teapot without a spout, but okay. And now this should be to scale, and when you export it, it will be to scale. Save the scene. No questions? No. We don't want any permanent damage to anyone here. That's. Oh, all right. We'll do our best. So, yes. Other questions? No, I can't. Yeah, we can. It's not required in the course, but we can certainly look at that. Hmm. Yeah, yeah, but you would need something to bake. So this this arguably is not too high for in-game, not at all. You would get rid of unnecessary vertices, but if you look at this, all these vertices are actually contributing quite nicely to the curvature. If you see that, like, this would be what you look at. You would not look at the subdivided result, but here, it just depends on your unit, whatever it is that you're making, but you would start sacrificing edge loops, right? So maybe that could go, maybe this could go, maybe these could go. Anyone that are not really contributing to the curvature, but you'll find that a lot of these do. I can't really successfully probably not get rid of that, you know. So anything that would kind of be more the challenge, but we could certainly look at baking normal maps, but you would need to have something to bake. So in other words, this would, there would be nothing to bake because there is nothing there. The only thing that arguably could be more efficient would be the poly count, which is what you're doing here, or start adding like making tries and like, you know, yeah, yes, but yeah, we could certainly look at baking normal maps, but that would be more for having some surface detail that you now want to bake. So if for some of you, if you're interested in that, we could look at it. It would be outside of the kind of the, oh, look at that, that's nice. Ooh. Be outside of the mandatory assignments because you would probably need to sculpt something or have some, maybe in Mudbox, if you don't want to get into ZBrush, sculpt something, or even have, we could look at it technically, like how would you bake something down in Maya also, just sculpt the high resolution version. But yeah, okay, yeah, we'll do that. We'll do it. We'll do it. We'll do it next time then, because we're looking, then we'll start looking at UV mapping and texturing. So you would need UVs anyways to bake anything. So that it would make sense doing that. So we'll do that as a little bonus for those who are interested when we're talking about texturing. Yeah, and let me just think of some relevant examples for you. Where were we? What was I doing? I was going to do something. Oh, never mind. Yep. Other questions? Huh? Get tea. Yeah, let me 3D print this and we'll have a tea party. Yeah, yeah, but we'll have tea, essentially. Uh, so let me, if some of you want to take off, it's okay. I mean, that kind of concludes what I wanted to cover. This will be what we'll be doing in the lab for those of you who want to be there, or I could look at any of your models or give you feedback, or if there's anything. Essentially, we want to address concerns you may have today. Uh, Next time, we will be doing UV mapping. So that kind of requires you to be at a stage with your models that you're kind of happy with. Because, yeah, we're leaving modeling here. So this will be quite intensive as well. Learning UVs and then doing a simple texture. And then based on your interests, we'll also kind of add on to that normal map baking and stuff like that. But that would not be mandatory. But it's very, very interesting. And yes, completely relevant for everything. So yeah, so if you want to take off, feel free. I'm gonna just show like 5 minutes how you can set up like some simple materials. In case you're tired of looking at gray models. Uh, would anyone want to see that? Who wants to see that? Okay, so I'll do it if someone wants to see it. Yeah, so In Maya, there is a render engine called Arnold. Arnold is very powerful. It's named after Arnold. Yes, the Terminator, the Governator. It is named after Arnold, just because it's a very powerful render engine. Because it just uses kind of brute force, throws large numbers at the problem, and renders beautifully. So Arnold is great, and now it's implemented in Maya, so that's excellent. So if you want to start kind of getting a little bit into adding some more sophisticated materials, you're only a couple of clicks away. So if you click Arnold right here in the hypershade, you can add, bye, bye, bye. You can add AI surface, AI standard surface. With this material, you could do like 98% of everything uh, in a very, very realistic way. So this is a much more physically plausible material than the Blinn or the Lambert or any of these. And again, this is a little bit outside of the scope of the class, but it's certainly kind of, it's not very much different necessarily. Uh, Same thing, I can apply this material. So the problem, like if I'm going to start making this look like glass, and again, this is, again, you don't have to worry about this at this stage. It's just in case some of you are bored of these gray models. Then there we do have something called image-based lighting, which is quite useful. This is a topic that's too advanced for this intro class, but it's actually not so advanced to quite simply do without necessarily understanding everything that goes on, right? You can literally here in Arnold, you have an Arnold tab, you can create lights. So you have area light. These are excellent lights. Where is this? So if you do a sky dome light, it will create kind of a dome light around everything. So let's just try to add also. Let's make another AI standard material. So AI standard surface, that's the one you want. Like I said, it's kind of a do it all kind of a thing. So this would be the teapot material. Oh, teapot mat. And let's make another one. AI standard surface. This would be the table. So initially, we could just try to render, and I think it will be immediately kind of more pleasing to look at. So we can go. Arnold has its own render. You can look at that if you want, but let's just use the standard. It doesn't really matter. Where did it go though? Here. This will appear on your monitor on the lab. So you go to the render view. Here you have the render globals. This is just all the render settings. You don't have to get into all these, but one little important setting would be the perspective or the resolution, right? So under presets, you have some, whoops, where did you go? Under presets here, you see we have, HD, all this. So this is set quite low initially, which is kind of nice if you're just look debbing and we're just rendering to see what this will look like. So if I hit render, it will render using Arnold. And now when we are using Arnold, we do want to have Arnold materials applied. So don't use a Blinn or a Lambert. It's just AI standard. Okay, so now it's just flooding the scene with this material. Okay, so we could start adding more lights and so forth, but if we want to start look debbing or kind of approaching something that would look more like glass, the problem we're actually dealing with right now is that we don't have any environment. There's nothing there to be reflected in the glass. So when you're looking at glass or metals, what you're seeing is reflection, right? A lot. So when there is nothing to reflect, it's very difficult to achieve that look. So this would not be a problem for you probably if you already have built out an interior. Like if you have a kitchen scene and you're starting to render, this will be a little bit more interesting for you because you will see things reflected in here. You will have an actual environment, okay? But if you're doing exterior scenes in which it might be difficult, or when you're look debbing, kind of what we're doing here, just doing quick renders to see what this would look like in an environment, we can use an image and basically apply that image to this light. That's kind of a topic called image-based lighting. Again, this is a little outside the scope of the class, uh, but essentially uh, we would be using images that are actually stitched together in a way that they would wrap around the sphere very nicely. Okay, so this panoramic images that are stitched, essentially they're only images, but they're wrapped in a way that they can be easily wrapped around a sphere, spherically mapped. So typical formats for these would not be your standard PNG or JPEGs or even TIFFs or Targas, because we don't have the sufficient bit depth in the image. So this, again, larger topic. But we need essentially more information in the images. And we have specific formats for these images, which you might not have used before. So HDR is one format. It's just a format, like JPEG is a format. HDR is a 32-bit image format. It just contains much, much more data, ridiculously much more information. So 32-bit images is what we use. So HDR or EXR is another format. So EXRs or HDR. It doesn't matter which one. I think Arnold actually prefers EXRs, but HDRs will be totally fine. So how do we get those EXRs? You can probably find a lot of them online. So like EXR image-based lighting. I don't know, EXR. Yeah, here, like there's a simple image-based lighting archive. This is free. There are resources in which you could find these, but these are also on the server. So if you go to the MMT logger STE, if you type that, you will get to the server if you haven't already, and then MMT teaching. I put some in here at least. So Jules, if you find me there, and resources, I did put some HDRIs here. So HDRIs, yeah, so high dynamic range images. 32-bit images, they have more range. Like, so the way you take these images, you would take more exposures. So if we were to replicate this room, you would take a lot more exposures than you would typically with one image. Like if you take a photo, you have to sort of either expose for you guys who want to see you clearly, right? Or yeah. But when we do these HDR or these high dynamic range images, we take multiple exposures of everything. So a lot of exposures, like maybe like 5 to 7 or 8 exposures, like that way, this way, that way, and top and bottom. Or if you have a fisheye lens, you'd only do it that way, and you can do it 4 times. Anyways, and you stitch it all together, which is less work than it sounds, depending on which tools you might use. So anyways, so simple image-based, this is basically that, at least some of them from that library. So let's see, Alex's apartment, here's one. So see, this is an HDR file, so it's not an EXR, but it's okay. HDR, pretty good. So we can copy that, Control C, and I'll copy it in there, Control V. It's just taking it down from the server. And then we can open that with Photoshop. And there's Alex's apartment. So this is an HDR image. It means that there is much more information here than we can actually view on this monitor. So again, this is a larger topic. This is why most images would have an sRGB curve encoded in them and so forth. All of these topics become very important to understand rendering and have a linear workflow and all this. Much, much more advanced topics, but we don't have to really know any of that to basically just use this in a kind of pragmatic way, just put it in there and see what happens. So adjustments, exposure. So a lot of Photoshop had to be, or is currently being, rewritten, not just adding on to existing code, but actually being rewritten because you can't just use the same tools that worked for 8-bit images and apply it to 32-bit images. So it's a kind of a completely different world. But here, essentially, you see that if I go way down in the exposure, you see there's information there even here, but there's also information in the dark areas, like even under here. This would be typically lost, right? You'd have to sacrifice some of this information in one image, but here, everything is here. This is why this is so extremely useful for not only for reflections, which we're going to be doing, but also for actual lighting. So we're going to be doing both at once when we're attaching it to the light source. So I'm going to copy this HDR, we're going to put it in the source images. And we're going to try to see if this works. So here, go to the attribute editor for the light. This is sky dome light. We can put it in the color, I believe. File node, again, I'm going to turn this up. The filter type, and I'm going to find the HDR. So there's just a lot of clicks, getting this set up. Once you have it in there, we can actually move around. And it seems like we're in the room. It's just because we're inside the sphere, looking at an image which is spherically mapped onto the sphere. Maybe you've seen the QuickTime VR, like movies where you can look around. This is the same thing. Some people call this VR, which is totally not. It's not VR. It's just you can look around a sphere. You can't, Anyways, so yeah. Yes. So okay, let's do another render. Now it will actually use this as a light source, so that will be interesting. So all of those reflections are obviously reflections we get from the HDR. Depending, what's that? Yes. So you select the light, and then we can go down here, and there's a visibility. So there's the visibility in the camera. You can set that down. It should go away now, at least when we render it. Yeah, so now the image will not be there. Essentially, we're just using the image to get the lighting and the reflection. But yeah, so I also prefer that because we're just using it to look at, so we have something to look at, right? Okay, so that's cool. Depending on the GPU, let's see what will happen. So press 6 and 7. Yeah, this is not too bad. So now it's obviously just using the GPU and giving us a real-time preview of all of this. And here in this viewport, we can activate screen space ambient occlusion, which would give you kind of contact shadows, or at least try to give you. And here, I believe, shadows, which is not so successful. So here, I would probably, which is also kind of a common thing to do. So we can add like a directional light source. For Arnold, I wouldn't use any of these other light sources except the directional light. The directional light it works totally fine with Arnold. Otherwise, I would use the Arnold lights. How about here? So we could do like a directional light. The placement of the directional light doesn't matter because it's just it's kind of like if light were coming from an infinite light source somewhere. So that means the placement doesn't matter. The only thing that matters would be the rotation. So here I'm going to use this also to kind of make light coming from that general direction, perhaps, maybe because there's a lamp there. I'm just going to also use this, but it seems like, let's see. Yeah, maybe you'll have more success with this on the lab. Maybe there are better GPUs there. I don't know. Maybe not. This should now actually yield a shadow here being cast, but it's not. So it's okay. It would be, again, a little bit more convincing if it did that. Let's try to render it. So you would have to render it to see sort of what it would look like eventually. Render. So we should see a shadow being cast from the light. No, we're not. Why not? That is odd. Maybe it's just because this is so bright and the other one is so not bright. If we turn up the intensity of this guy. Oh, okay, so it was actually, oh, the issue was just the direction, so point it a little bit down. There we go, have the shadows. Okay, so maybe for the color, we could sample the light source over here or something like that. So now we have that kind of color. Yeah, so, okay, so it did show up here. That's nice. Let me lower it a little bit. So that's actually, it's actually kind of common. You can help a little bit with the HDR. You don't have to rely 100% on the HDR, but then just add some additional light sources. And yeah. And then obviously the material then, so if we go into the material, so this would be the material for the teapot. So we have a roughness slider. This you would have to just try. Let's see if this doesn't seem to give us an update. Probably this might work better on the labs if the computers are a little bit more spec'd out. We would see the reflection becoming a little more rough, not so bright here. Yeah, so you see, you're not so many clicks away from at least just having fun with these materials, and you're no longer just looking at extremely gray, dull world. So, yeah, 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 yeah. So it's doable. Just add a light, play around, have some fun. Next time we'll start talking about UV mapping and texturing. There is something called tileable textures or seamless textures, which you could apply without necessarily worrying too much about the UVs. So if some of you want to do that, just to get started adding some textures, so I can say like wooden seamless texture. Let's add this. This is a one-to-one image. Okay, so that's nice. So open image, whatever. Let's look at that. Ah, okay, looks nice. So this is seamless. We will talk more about this next time. But essentially, if it's seamless, it's just a little JPEG. I can go in here and add it to the color of the table material. So where's it? Wood. And then since it's seamless, I can actually go to the place to the texture node and repeat the UV. So if I set this to 4 times 4, it will actually repeat that wooden texture and you can't really notice it. And you could do that. Add seamless textures even without UVs, or just make automatic quick UVs. And so that's a quick way to add seamless textures to something if you want to start just looking at having textures there. But next time we're going to deal with customized UV maps and how we can then make customized textures fit more to the object, sort of. All right. Okay. Well, I'll see you in the lab. So yeah, yes, you know the deal. First group first, second group second. Mm-hmm. Mm-hmm. Hmm.